Hi everyone, welcome to our first official Build Hour. We're super excited to have you here today. We have an action-packed hour on all things function calling. My name is Sarah Urbonis. I lead startup marketing here at OpenAI, and I'm joined by Joe. Joe, do you want to introduce yourself?
Yes. Hello everyone, I'm Joe Beatler, lead solutions engineer for the API platform team at OpenAI.
So as mentioned, this is our first Build Hour, and we really created this with one goal in mind. And that's to empower you with all of the best practices, tools, and AI expertise to scale your company using OpenAI APIs and models. Now, we created this series based on what we were hearing from you as topics you wanted to learn more about, and we really want to make sure this is the most valuable hour of your month. So in order to do that, we would love to have you use the Q&A function so you can ask questions as we're going through the content. We'll be reviewing them at the end as well as throughout the presentation, so we'll be answering them in the chat. So let's dive into how we will spend our time today. First, we'll get started with understanding function calling. This is really going to be the basics and foundational building blocks around what function calling is and how it's used. From there, we'll talk about how to improve consistency and accuracy of function calling. We'll talk about some of the strengths, limitations, and best practices to get you started. From there, it's really going to be where rubber meets the road and using function calling in production. We'll show you some examples of how to apply it to customer service use cases and other multi-agent systems. And finally, we'll talk about troubleshooting issues. As mentioned, use the Q&A function so we can answer your questions at the end, and we'll also give you some resources so you can be ready and rearing to go. With that, I'll pass it off to you, Joe, to start with understanding function calling.
Great, thanks, Sarah. So we'll start at a high level with understanding function calling. Just really quickly, I want to give an overview and just kind of define what function calling is. So really, it's the capability for OpenAI's models to intelligently choose to output a JSON object containing arguments to call one or many functions. And the chat completions API, which is where we fundamentally use function calling today, does not execute the function, but instead allows you to call the function in your code. So a couple of high-level use cases that we'll go through in a little bit more depth. You can use function calling to create assistants that answer questions, convert natural language to API calls, and extract structured data from text. And as we go through the presentation, we'll cover kind of really high level what are functions, what is function calling, how it works, some examples, and how it's used. I know this is most likely a developer audience, so this is going to be a very high level for some of you, but we'll jump into some of the deeper topics in a moment. But I want to start by just baselining what are functions. So functions in Python are like recipes. Imagine you have a recipe for making a sandwich. This recipe takes some ingredients like bread, cheese, and ham, and then you follow specific steps given those ingredients, and finally the output is a sandwich. So in programming, a function works similarly. It takes some input. We call these inputs parameters or arguments. And then the function will do something with them, with those inputs, and they will follow the steps defined inside the function and then give you back a result, which we call the return value. So in this case, you look at our kind of the definition is the keyword that we use to define the function. The make sandwich is the name of our function. And then you have bread and filling are the parameters that we need to be able to work with in order to make our sandwich. And then we return the output, which is that fully made sandwich. So I'd like to start with the kind of defining high level what a function is so that you can understand the difference between what functions do and what function calls do. Function calling is a tricky concept, and it can be a little bit difficult for developers to understand. And because of the name, we often see people get a little bit confused or have concerns about what our models are going to do with their functions and with their internal systems. So I always like to clarify that what they do is enable the models to select a tool. So we're going to use that tool and function a little bit, go back and forth between the use of those two. So you basically have a list of options that are described in a prompt. So it's able to select that tool, and then it allows you to generate and return function arguments following the provided specifications. What they don't do is they don't actually execute any code. So you don't have to worry about us mucking around in your systems. They don't allow our models to interact directly with your internal systems or APIs directly. They basically allow the model to choose from the list of tools to let you know, based on the interaction that it's having with the user, what functions you should execute or what internal APIs you should call that allows you to start to build kind of automations that actually plug into your backend systems. I want to walk through an example of what a function call is. So say we have a list of functions. In this case, you see in the blue, we have get weather and get location. The LLM can dynamically select from the list the correct function and parse its arguments. And this is going to be based on the actual input that it's getting from the user. So for example, if the user says, what's the weather in San Francisco? And we have a list of functions that have to do with questions around weather. It's the model is then going to select the get weather function and the location is going to be the parameter that it knows that it needs in order to return. So once it has those two, then it can pass you that information, which is basically, hey, based on the user's input, the function that you should use is get weather, and the arguments that you need is San Francisco. That's the location where the user is looking for information about this. So then you can go off and plug that into an external API or do whatever you want with that and return that information to your user. So I want to walk through step by step how this works. First, from kind of the user interaction perspective and what's kind of how the life of the function call. So we start with a user question where the user asks your chatbot or agent a question. Then the question and the list of functions are sent to the model via the chat completions API. So at this point, we have our function list, which we mentioned previously. This is a slightly different use case. Imagine it's more around like e-commerce, like an e-commerce chatbot. And we have the, like initiate return and request refund are the types of actions or functions that we're going to use here. Then the model can determine which function, if any, should be called based on the user input. So in this case, the list of tools is initiate return, request refund, and some kind of fraud question. And so for each of these tools, there are different arguments or parameters that the model is going to need to collect before it's able to return that function call. So in this case, in order to initiate a return, you're going to need the order ID and a customer email. And to request a refund, you would need the reason for the refund and the date of the incident or something along those lines. And so these are parameters that you completely control. It's basically whatever you need to kind of execute in your code, you can define those as your parameters. Then the model is going to identify the function arguments that are required to call the function. And if the user has not provided the context needed for the model to determine the arguments for the selected function, the model will try to get that information from the user by going back and forth and kind of responding with a question, asking specifically for those parameters that are needed. And the model will continue to ask the questions until it has all of the required information to generate the function arguments. So this is a very powerful tool, but we will also talk into how this can get you a little bit tripped up, and you don't want to get stuck in like an infinite loop of the model asking questions and the user not being able to answer them. So once the model has all of the information that it needs, it will then output a JSON response that includes the function and the arguments. So this follows the schema that the developer provides via the chat completions API prompt. So as you define the actual tools and that schema, we'll look at that in a second. And then with this output, the developer can then execute the next step in the code that calls the function with the provided arguments. So it's very common that you would have a function in your code that is called initiate return. And then when you you just do a string match on the tool that's returned, and then you know that that's the function that you need to call, and you have the arguments would most likely match the parameters that are returned by the tool calls as well. So an example of what function calls actually look like in code is we start with the tools and prompt, and we go through kind of the names and descriptions. So at a high level, you start with the user asking a question. They say, I need to return my order. The ID is 1234, and the email is me@example.com. Those are clearly the parameters that we're going to want in this function. I'm including those in the default response, but most likely it would take a couple of terms because not everyone's going to provide the information that's needed to process that return up front. So if we look at the input tool schema, this is just going to be an array that you write into your code. In this example, we're just looking at it as JSON. So you define that as tools. You then have each tool has a type, in this case that it is a function. And then each function has a name. So the name in this case is get delivery date, and the description is get the delivery date. It's fairly straightforward. We then also have a function for initiating the return. So we then are able to pass that tools as a parameter to the chat completions API. So if you look at this as like an actual API call in Python, you start with the model that you want to hit. So most likely GPT 4.0 in this case. You also have messages, and it's important to pass the array of messages for the conversation, as the model may need multiple turns before getting all the information it needs from the user. So for example, if I did not include the ID or my email address, then the model would need to respond back and ask for that information specifically. So you do have the option with the chat completions API to basically store the state of the conversation history and basically queue up the messages and then pass those as an array to the model. Or you can just pass a kind of a one-off string as a message. In this case, when you're using tools, you're going to want to make sure that you are maintaining the history of that conversation, because I might say, I need to return my order, and then the model says, great, what's your ID and email address? And then I say, my email is me@example.com. And then the model is going to return back and say, great, now I need your order ID. And then I say, my order ID is 1234. So that's going to end up being 3 different messages that have like the actual intent, which is the tool that needs to be used. And then separately, we'll have the 2 parameters. So if you're not passing all of that information back to the model after that 3rd turn, then it's not going to have the complete information. And it's just going to keep asking like, great, I need your email and ID. And it's going to get confused and kind of be a bad interaction at that point. So once we have that defined, we again pass the tools as a tool parameter. We have tool choice, which the options there are basically like auto, if you want the model to be able to determine whether or not it should use a tool. It could also be required if you are requiring the model to choose a tool, or none if you don't want the model to choose a tool. Which I don't know why you would pass tools and use the function calling syntax if you didn't want the model to use it, but that is an option there as well. So once we have that request, that's going to be sent to the LLM, and then the model will output the JSON response. And so this is going to come in the format of, it's going to have function, the name of the function, and the arguments, and whatever arguments were included by the model. And that will be passed back as, so you could then use this structured data to do something in your system. So whether that's calling a function, calling an internal API, maybe you're like initiating a return and then sending an email confirmation, and all of that happens. And then once you finish doing what you need to do in your system, you can have the model respond back or pass the output from your external API to basically say email successfully sent, order return initiated, and that will pass back to the LLM that'll process that, and then it can output and say, great, your order ID 1234 has successfully been returned. So that for the next step, we want to go through some of our tips and tricks around improving consistency and accuracy. So this is basically some of the best practices that we've found with function calling. As I'm sure you all know, working with LLMs can be a little bit tricky, and a lot of times it is like working with a human, and more so sometimes it's like working with an intern that may not have all of the context on all the tasks you're asking them to do, and so you kind of have to learn how to coach it to do things the way that you want them to be done. So to start, we basically say the most important thing that you can do with function calling, and oftentimes when we're helping people troubleshoot issues that they're having with function calling, we find that they just are not naming their functions intuitively or using detailed descriptions. So unlike when you're writing code, when you can use lots of abbreviations and shortcuts to try to basically shorten the code that the number of lines or the number of characters that you're using in function definitions, this is a time to be a little bit more verbose and to kind of tell the model exactly what you want it to do. So something like initiate return sounds pretty straightforward. You might even have initiate return for item or something if you find that it's having a hard time selecting that. So you'll make sure that the function name is interpretable and uses natural language. We would also want to include descriptions for when you want a tool to be called, and include the descriptions of the parameters for complex functions. So if you have multiple parameters, you're going to want to say, this is the this is the function that you will choose when a user is trying to reaches out because they're trying to return an item. And then you might describe each of the parameters. Obviously, that's a fairly straightforward example. But if you said the order ID is the ID that we give to the order to make sure that we're able to pull the right order from the database. And so sometimes giving it context on like why you need that information too can help it understand how that data is actually going to be used. So the second big tip is to use enums when possible. So this helps constrain the possible values for parameters, which can help reduce hallucinations. So if you're doing something like, you have a chatbot that's helping somebody order a t-shirt, for example, you have a fixed number of sizes for those t-shirts. You might also have a fixed number of colors or styles. So if you had one parameter that is sizes and one parameter that is style or colors, then like you could just pass an enum for the specific arguments that you want the model to select from, and that will keep it from like freestyling too much and going out and trying to kind of making up an answer for what it thinks a cool t-shirt would be or what it thinks your size is. So it's going to pass, and that'll also be if you're looking for a specific structure that's important. So maybe you want L instead of large, and so you have S, M, L, XL rather than small, medium, large, extra large. If you pass it those specific, enums as examples, then if somebody says like, if it says what size is the t-shirt you want, and I say it's size large, then it will know that it's supposed to use L instead of large in that context. We also want to look at evals, using evals and adjusting your functions based on failed evals. So if the model is routing incorrectly between two functions, you want to make sure that those functions are unique and differentiated. So there's sometimes where you're trying to have the model do things that are kind of too close to the same function. And one of the ways that that you're going to pick this up is during your evals. So if you are using actual requests that you're getting from users, or big synthetic requests that you made up that you think are questions that users might ask, then as you want to make sure that you're running evals to try to find those edge cases or areas where somebody might have a more ambiguous question or ask, and the model is going to have a hard time parsing between which action you want it to take. So in that case, you're going to want to make sure that, you could consider more advanced techniques like fine tuning to correct the failed evals, and you'll want to include those types of edge cases and the hard things that you want the model to get right in your training data for fine tuning. And then we also sometimes recommend that you include the tools in the context. So, you have to remember that the tools are included in the basically the system prompt for when we pass all that information through to the model. So since they're included in the model context, if you run into unexpected context window limits, you may not be considering how tools contribute to that. So sometimes people will reach out and they'll say, like, I'm getting an error saying that I'm hitting my context window limit, but I ran like a tokenizer test and I'm well under it, what's going on? And if we don't know that they're using function calls, then you may just have a lot of information, a lot of tokens in your function, in your tool definition. And that might be eating against your context window and passing you over the limit there. So something to watch out for. Another kind of fun tip is that you are able to force function calls. So you can force GPT to use a specific function. There are some scenarios where you might want the model to just do one specific task and you only want it to collect the information to do that single task. And in that case, you can force it to use one function, but you can also just force it to at least use a function when function calling. And this is a fairly recent capability that we've added. So that might be something that wasn't available the last time you looked into function calling. So when you are forcing, so we do have a resource that I have mentioned here, which is our using tool required for customer service cookbook. So that's just at cookbook.openai.com. And if you go through that cookbook, it'll show you how you might force the model to select from a function. But when you're forcing the model to select a tool, you must provide escape hatches so it doesn't get caught in that loop of kind of infinitely trying to figure out what the customer wants or the user is trying to do. And so that's the next tip, which is you won't need to provide functions to cover all scenarios and reduce hallucinations. So you may have a list of operations around like returning an item or something that has to do with like your e-commerce store, common interactions that you would have with a user. But in this case, you may also have something like general, like an ask function, which is basically have the model ask the user questions to help determine which tool to use. So if I come in and I'm talking to your e-commerce chatbot and I say, hey, what's up? then like the model is not going to know which function what intent I have, which function it should use to start helping me in that context. So providing it a tool that's just like ask would be helpful, because then it'll respond and say, hey, what can I help you with? Or something along those lines. The other concept that is important is if you have a human in the loop, which we typically recommend, and we'll get into that in a moment, but you want to have some kind of like escape valve where they can escalate to a human. So you make sure that it has a way out and it avoids getting caught in a loop. So if the model's having a hard time, I've seen some people kind of process it so that if the model does 3 turns without selecting a tool, or 5 turns without selecting a tool, that they automatically want to escalate to a human because they're concerned about the user experience of somebody, the model is having a hard time understanding what that person is trying to say. The next is to add details to the prompt. So there are times when you may want to include the function list in the system prompt if the model frequently forgets to use tools. So even if you have beautifully defined tools in your tool definition and you're passing that through as the tool capability for the model, sometimes it just won't select them frequently enough. So I usually like to have kind of a list of tools and maybe even the parameters, and just kind of remind the model in the system prompt, like, you have access to these tools, here's the list of tools. And usually you don't have to be as verbose with like describing when to use each tool in that context, but that can be an unlock if you're finding that the model is frequently forgetting to use its tools. And then the other thing that we'll mention is that sometimes there is additional prompt engineering that's needed. So that's like one form, is just like notifying that it has tools. But if there are like specific scenarios where it's having a hard time, you can either update the descriptions, or you can also kind of really emphasize what tools should be used when in the system prompt as well. It's a little bit repetitive, but models, just like interns, sometimes need instructions to be repeated. We also have kind of a trick for dynamically adjusting which functions are available. And so typically, as a rule of thumb, we see that the models don't perform super well when you pass it more than like 20 functions. So if you do have scenarios where you have like 50 functions or 100 functions, then usually the recommendation is to break that out into multiple agents and have like a triage function that can select between them. We will go through that scenario in a moment. But this is also kind of an interesting trick. If you do have an application where tools might only be available in certain scenarios, then this can be an interesting practice. So for the example that we have here, imagine you have an assistant for a car, and the driver can ask the car to do different things. So there are going to be different states that the car will be in. So for example, if the vehicle is driving, then you will want to make sure that you aren't able to do things that you wouldn't want people to do while they're driving the car. So if the user says pop the trunk and the vehicle state is driving, then you're going to basically have a list of valid functions based on that state and a list of invalid functions. And so this allows you to kind of control them a little bit more using these deterministic rules to figure out which subset of the functions we provide the model in the different scenarios. And this will help increase the accuracy and prevent invalid calls. So in this case, if you're basically saying, I want you to pop the trunk, but the car is driving, the LLM is going to have an escape valve in there as well that can say, I cannot currently open the trunk for you. And so you can imagine there are other applications where you might have some scenarios where you need some functions to be available and other scenarios where there'd be other functions. And if that allows you to kind of keep it under the 20 function limit, then that would be a great best practice, rather than having to kind of do something advanced like fine tuning for function calling, or go into, or like break it out into multiple agents, which can then be a little bit less efficient. So hopefully that answers a lot of the questions that we got in ahead of time. We do see these as kind of some tips and tricks. So hopefully you all find that helpful. So for this last section, we're going to talk about how you use function calling in production. And there are 3 technical patterns that we see at a high level where people have a lot of success using function calling. And so it can serve several purposes, and these are kind of a few of the common technical use cases. So first would be a Q&A chatbot with tools. I think this is what everyone kind of first intuitively thinks about. We've talked about you can have like that Copilot chatbot that calls internal tools and APIs. This can be a customer service bot that can query and edit customer data, handle a lot of those interactions that are more transactional. There is also a scenario where you can use function calling to process natural language and convert that to structured data. So you can translate the natural language inputs into structured data, and that you can use that to generate SQL queries from user input. And an example of this would be like an Alexa smart home. I also worked with a customer that was basically allowing people to use chat to create like movie queries or like query for TV shows. So like imagine within a streaming service, you're like, hey, I want to watch like this type of movie. It could then like parse and give them kind of very specific structured information around genres or actors or whatever it is that they were looking for. And then that structured output could be used to run a more deterministic model, like an ML-based model, to kind of search for those types of things. The third scenario is fine-tuning for function calling. I mentioned this a couple of times, but when you have a lot of kind of ambiguous language, or if you have 50 plus functions, or if your functions tend to be kind of very similar and hard for the model to decide between, fine-tuning can be a good solution for making that more efficient. You can also use this for both for production data, or you can use synthetic data to fine tune. And so an example like this might be that voice assistant in the car. There's a lot of actions that you want it to be able to take. If you aren't able to kind of break those out based on context, then fine tuning can be a good option. We aren't going to go into fine tuning for function calling on this call, but our next session, our next build hour will be on fine tuning, and we'll be able to cover that then as well. So please send us questions if you do have follow-ups on fine-tuning for function calling. I want to walk through one case study. And so an example of what a function call actually looks like in code. This is kind of the high-level process that we go through when we think about customer service. And customer service is a little bit of a boring use case, but it is very valuable, and it is something that we are working with a lot of customers to try to increase the amount of automation they can do in customer service. But this also is a great framework for a lot of other different types of use cases. So you basically start with a tier, what we call tier 0, which is our triage step. This is where you're trying to get the model to determine the intent and gather simple details from the user. And so you can see how function calling would be valuable there. Then at tier 1, the support, this is going to help solve low complexity cases and escalate high complexity cases. And so that's where kind of selecting from available functions that could be potentially fully automated would be valuable. Then we also have our tier 2 support, which is basically an escalation if the tier 1 agent isn't able to handle it. This is where you're asking for a supervisor, or trying to get somebody that's a little bit more knowledgeable about your specific situation. If it's more complex, that would be escalated, and then that's where you'd solve the high complexity cases. We then also have a stage of case resolution, which is kind of making that final decision, recording the notes and next steps. And then moving on to a root cause analysis, where you're trying to identify the failure points, logging how the model does or how the human agent does, and then diagnosing any failures so that you can update your processes around those topics. So this is where we get into some of the good stuff. We have a high level what like a multi-agent solution architecture would look like. So if we start here, you have your user that they're going to be asking the question. We then have our first agent, which is going to be that triage agent. They will have access to the tools, which are the function calls in this case. Once they kind of handle that and figure out which tool needs to be selected, they can then pass off to the tier 1 assistant. So that would be a separate assistant that could also have access to tools like function calls, or use things like RAG to pull in information from a knowledge base. And then at that escalation path, this is where we see that kind of AI assistant or copilot use case, where you would have your assistant, but then also a human that is basically going to accept or reject the outputs from the model, and help them handle these more complex cases a lot more efficiently. And so that's where you might have, you might want a human to approve kind of going in and like processing a refund or something that has a big monetary impact, or something that's higher risk for your business. You would have them, the model be supervised by a human in that scenario. And then we also have the case resolution, and the RCA could be a separate assistant to kind of go through some of those offline things. So to go a little bit deeper into this, we have our LLM at tier 0, identify the intent and route to the right tier 1 prompt using function calling. And so right here, we only have one tier 0 router, and we only have one tier 1 assistant, but it's possible that you could have multiple assistants at the tier 1 stage. And so sometimes what we'll see people do is they basically try to have the user input come in, and then have the model select between like 10 different assistants. And that usually isn't a great, like the model just doesn't have a great job of figuring that out. And sometimes the user's initial question that comes in can be a bit ambiguous. And so in that scenario, we want to make sure that we aren't picking the wrong tool, because if you pick the wrong agent, then and say like it's a customer service agent, but really what I needed help with was, sales, then like that agent isn't going to have the tools needed to help me with my questions. So it's just going to end up in a failure mode and kind of having to escalate to a human. So in this scenario, starting with a tier 1 agent that's focused on kind of making sure that it has the initial intent and figuring out which agent it should route to, that can be a lot more efficient and create a much better customer experience in that scenario. Then we move on to the tier 1 agent, which is, again, going to have access to functions and things like RAG. So one of the things that we'll do that's kind of a cool tip is, instead of like trying to define all of the functions, like say you have 50 functions that you want this agent to be able to do, it's not going to do very well at selecting between those. You can actually embed those functions as kind of instructions in your knowledge database. And so based on the question that comes in from the user, it can go off and pull the policy from your knowledge base, and that can include the functions that are defined in that policy. And that's a way to kind of like hack it, or kind of a shortcut. Instead of having to define those as separate tools, you just kind of keep it more general and then allow it to go off and pull a routine that may have multiple tools. And so an example of that is if you had a process where you're like, I'm going to like initiate return as an example, maybe there are multiple functions that need to be called as part of that. Like first you need to go off and look up the user, and then you need to check the order status and make sure that it's within the return period, and then you need to go do two or three other things. Instead of having those be separate tools that kind of bloat the number of tools in your prompt, you can have that kind of defined within the RAG database. And so when it pulls that back, it will then have all of those instructions to then follow and return to your code to execute. We also then have our tier 2 human plus AI assistant. And so in this case, like the model, like GPT 4.0, Copilot can gather relevant data from the tier 2 human agent, and it can also suggest the next best action. So the goal here is for these complex interactions where maybe they need to ask a lot of questions from the customer. That can be time consuming, especially for something that's async like a chatbot. They might be going back and forth with the customer over the space of 20 minutes because people aren't going to respond right away. So if you have the AI assistant able to do that and also able to respond right away every time they send a response, that's going to keep the customer more engaged. And then once they reach the end of that, once they have all the tools, then they can return all that information up to the human to make a decision based on all the information that was gathered. And this is also a lot of times where you would kind of plug into external APIs. Maybe your tier 1 assistant would have access to APIs that do lookups or try to answer questions from a knowledge base, and are just kind of like doing read-only type operations. But you would need to be pretty confident before you hand off kind of write operations to your agent. So a lot of times those are supervised by the tier 2 assistant. And then we also have this concept of an RCA assistant. So this is basically, you have the model. Usually you can use a smaller model. We see a lot of open source being used here, where you're basically just trying to go through the backlog of all of the interactions that you've had with customers and try to like rate or figure out like whether or not the model or even a human agent does a good job of interacting with the customer. And like in this case, when you're using function calling, it would be really important to use this as kind of an eval set for the model to be able to go through and make sure that the model is selecting the right tool based on the input. So you could say like, based on the user saying like, hey, I want to return this item, like did it select the initiate return option or not? So that is our kind of high level framework. So we'll go in a little bit deeper into what this specifically looks like. But we focus a lot on this triage agent because we think this is where a lot of people are missing something that is really critical. As I mentioned, like being able to figure out which agent should be used. So we're going to cover this as making sure that it picks the right assistant, and we refer to this as like intent resolution. So just this step is really important to make sure that you figure out the intent that the user is coming in with. And simplicity is key here. So the solution with the least handoffs will be the fastest and most reliable. We see a lot of people that are quick to kind of like chain together a network of assistants, but really we recommend using one assistant with as many tools as is viable before you start breaking that out into multiple assistants. And in this case, like it allows us to have like a one-to-many relationships. So you have one assistant and then that to do the triage, and then many assistants that help with specific tasks that are specialized, instead of having like a chain of assistant where you're passing from one to the next, to the next, to the next, and things can get a little messed up along the way. So as we go through the triage assistant, and we talk about this being a tool using assistant, a tool using assistant has a tool or tools for every intent. So you're going to need to make sure that you have those well defined. What are the reasons why a user is coming in to ask questions? And then you're able to stick with one assistant as long as possible before you split that out into a tier 0 and have multiple assistants. So once you do break from one assistant to adding multiple assistants, it does greatly increase the degree of difficulty. It also makes it a lot harder to evaluate because you have to make sure that, or you have to figure out at which stage it's failing. So we have a lot of customers that are actually able to handle really complex use cases by just using a tier 0 router agent and with multiple tools, and then like other things like RAG or that can pull in information. So again, we start with an example. This is a user that wants to return a t-shirt that they bought on Amazon on March 3rd. And the customer is based in Canada, and the product that they paid with was a credit card. So the details that we need here are the market and the product. If we pass that off to the tier 0 router, that's going to select from the available tools, and it's going to know that it needs to select a refund or a return. And then it's going to go off into the knowledge base and pull in the return policy. So instead of having like, a more deterministic approach where you have like, a return scenario for every different market and every different product category that you have, or like in this case, payment method, then you want to be able to kind of store all those policies in a knowledge base and then trust the model to kind of craft a query, embed it, and then go off and pull the right policy back from the knowledge base. So in this case, we have our return policies for, by market, Canada, Germany. There's, different ones based on the product or the country. And so once it is able to figure out that it needs to return, and it gets that information from the customer, which is which market is this and which how did they pay for this, then it's going to go off to the knowledge base and pick the correct return policy, which would be the return policy for Canada on the product credit card, and it's going to return that back to the model. And that is how we kind of get to that full resolution and kind of allow that to scale out by using embedded policies instead of just having many tools for all the different combinations. So as we scale to the multi-agent framework, this is what I mentioned a little bit earlier. You can kind of start with the intent identifier. And so in this case, this is like similar to like a e-commerce or it could be SaaS, whatever it is that the use case is. You're going to have multiple tools or multiple agents for each one of these different classes of tools. So orders might, just anything related to an order, there might be 10 or 20 different scenarios that you need to handle. So that is our, so if it selects the orders tool, you want it to be able to go and pull the policies or figure out what tools need to be used for each of these different scenarios. And so that's why it's important to handle the intent before you escalate there. But then there are also a lot of other different types of tools where you have like balance, maybe a balance inquiry, account suspension, billing and payments, or other types of scenarios. And so as we then escalate to, as it selects the correct tool, it can then go pull the relevant policies and continue on from there. So I think that's right about all of the content that we had. We did want to share some of these resources. We do have these all as hyperlinks. Most of these are cookbooks that are available, as I mentioned, at cookbook.openai.com. But we broke these out into 3 different types of categories, and I believe we'll share out this slide so that you have access to these. But kind of if you're just getting started with function calling, some of the basic concepts that we have, I'd get started with our documentation. It's pretty good. We also have this deck that we can share, and we have a function calling overview, which is kind of how to get started with function calling, available as a cookbook. And we also like the function calling tutorial from DataCamp. That's pretty good as well. And then for intermediate steps, we have a couple of more more advanced concepts around like handling named entity recognition, which is something that can be used. Function calling can be really useful there. And we also have like how you would do function calling with RAG. We talked about that as a few scenarios. We think that's more in the intermediate camp. Then we have some advanced topics. So I know there were questions around fine tuning for function calling. I mentioned we'll have our next session on fine tuning, but we also have a cookbook specifically around this topic that will give you an example and kind of walk you through a scenario where you can do fine tuning for function calling. We also have the more advanced concept where we talked about using tool required for customer service, trying to figure out how to make the model always select a tool if you're getting a lot of hallucinations or it's failing to select a tool some of the time. And then we also have a cookbook around parallel function calling, where you can see how, based on the user's input, if they kind of are asking about two things at once, you can go ahead and execute parallel function calls. So that is all that I had for resources. And we'll go ahead and jump to questions.
Great. And as Joe is pulling up some of these questions, would again encourage everybody to fill out the survey that we send out afterwards. We really want to create these build hours with content that is helping you build and scale on OpenAI. We very much see ourselves as a partner in your success building on our APIs and models. So if the topic that you were interested in maybe wasn't covered as part of this session, you want to dive deeper, maybe there's something else besides function calling, fine tuning that you want more info on, we would love to hear from you. So please make sure to get that feedback to us. We want to make these as valuable as possible. So with that, do you want to start off some of the questions?
Go ahead and jump in. So these will be some of the questions that we saw get frequent questions that we saw coming through in the chat. And then also we'll start with some of the questions that came through in your sign-up forms. So the first question I have is, how to provide few-shot examples for function calling in the user assistant message, or otherwise guide expected outcomes for function calling. Few-shot examples is something that can be used with function calling. I don't think there's a strict format for how we would recommend doing few-shot examples, but again, if you see that the model is struggling, kind of differentiating between specific function calls, then this is one area where you could basically just kind of outline a number of pairs, like key value pairs, where you basically have the prompt that the user is asking, and then the function that you would want it to return. And so it's just kind of helping it match, based on some of those examples, which tool you want it to use. And just like with any few-shot examples, 3 or 5 or so examples would usually be sufficient. But for the most part, I think we would recommend starting by making sure that you have really clear definitions and really clear names on your functions, and then maybe just reminding the model in the system prompt that it has access to the tools that you have defined there. Cool. So the next question that I have is, what's the difference between function calling and agents? So I think we hopefully covered this, but agents is basically the concept of having bot more or less that does something. And so that bot can chat with the customer. It can go back and forth. It takes in the input. It can also do things like RAG and have access to other tools. Function calling is just one tool that agent has to collect additional information and select from a list of actions that you want it to you want to be able to take in your code. I should also mention that we do use tools and function calling a little bit interchangeably, but the way that we've built this out is tools is kind of allowing us to have a larger platform of other things that you'll be able to ask the model to do. So function calling is the kind of main capability that we use within tools today, but there will be additional things that we're able to do in the future. And so next question, I have, think advanced parallel calls, 3 to 5 functions. What's the best way to, in context, teach model specific patterns of parallel calls? Say in scenario, X, prefer the specific sequence of function calls, H, V, J, and then B. Yeah, so that's interesting. So if there are, typically when we're doing parallel function calls, we see that, somebody's asking a question that just has 2 parts to it. And so if you want, in true fashion for parallel function calls, you wouldn't want to have a dependency between those. So if they ask kind of two questions. They should be able to be handled independently. If there's a scenario where you do want it to kind of execute a sequence of actions, that would go back to kind of what I mentioned, where you could use RAG to basically have the first call in that sequence, like pick a function, which then allows you to go off and do the RAG search and pull the policy or like that instruction set that is then going to have the list of other functions that should be executed based on that interaction. And so that's how I would look at it, is like parallel function calls. I'd usually look at wanting to be able to run those async kind of independently versus like having a set of instructions that's like a sequence. You could define that in RAG and then pull that back. Great. So for the next question, are there ways to chain function calls reliably? Like I have data that is generated by a function X, and this data is required for function Y. So I think we would handle that in the code itself. So the function is basically trying to help the model figure out what the user is asking for. So if they are asking to initiate a return, for example, that would be function X. Once the model returns the initiate return as the function, then you could then go and execute the code for the initiate return function that actually is an actual Python function. And then within that, you would just have your nested function where it kind of kicks off and triggers that next interaction. Handled that there. Cool. So for the next question, what framework is recommended to orchestrate the different agents in the customer service example? There are a few different frameworks that we've seen people use. I know LangChain is one that a lot of people have had success with. For the most part, like depending on the complexity of your use case, we see a lot of people building out kind of their own framework for like handling the handoff between the triage and the other assistants. This is something that's an area of interest for my team specifically, and it's something that we're looking into kind of how to do better orchestration. And so we've developed some things alongside our customers and hoping that we have more to share about that soon. For the next one, we have not switched to the tool syntax yet. Any benefits or things we are missing still using the older function calling syntax? So great question. That is something that we do see come up quite frequently. So the kind of most important thing there is that the tool syntax is the syntax that we're going to be using moving forward. I mentioned that like we will be adding additional tools to the models as we come up with more capabilities that the models are effective at. So that would be kind of like one thing is just future proofing would be getting migrated over. As far as immediate things that limitations that you would have is that parallel function calling is only supported on tools and not on the older functions. And you also will have more control over the behaviors. So for example, the required tool choice that I mentioned, you can have it auto or required or none, but that's only available if you're using the tool syntax there. Great. So that is I lost my thing. Okay, I'm a bit curious to understand how many fields one can add in the schema until it starts to drop in performance. So I'm not sure what we mean by fields here. I'm assuming that means parameters, but I'll answer both on, I think we covered the number of functions. We usually see like 10 to 20 as the range for the number of functions you'd want to have in your tool calls list. For the number of parameters, that's not something that I've specifically dealt with. I'm looking around the room, see if I can get some help. But I think we typically see kind of like 3 to 5 as the max there. But we do recommend, like with anything with LLMs, you can experiment and try to figure out where you start to see that drop off in performance. But for the most part, I usually see like 2 to 3 as the number of parameters that would be used. So just like if you have a function definition that has a lot of parameters inputs, that starts to get a little bit messy. I think it would be the same with like asking the LLM to collect that information. Cool. So we have, how can I enforce that certain parameters are dependent on each other? For example, I want to ensure that if parameter B is provided, parameter A must also be provided. Great. So with in the tool call definition, as you're defining the kind of data structure, that JSON array of tools, we do have the option to make a parameter required. As far as like dependency between those, you could define that in the description. So you would just want to be very clear, like in what scenarios you would be okay with only parameter B, but also be clear that like if it requires parameter B, you would also require parameter A. I'm not sure how that would look in practice, so I'd be interested to hear more about like the actual application of that. But for the most part, if there's a lot of kind of different scenarios, that might be something where you'd consider breaking out into different separate functions instead of kind of trying to cram a lot of behavior into one specific function. Great. So next question, if you already have a good workflow that returns JSON, but are not using function calls, is it worth it to switch to function calls? And if so, why exactly? That's a great question. We do see that people are asking like using JSON mode for pretty effectively instead of function calling. So I don't think that we would strongly encourage you to move to function calling. But if you find that the number of items in that JSON that you're trying to return, or that you're then kind of building out more scenarios that are handled in your prompt, that's where we would recommend moving to function calling, because that's just going to be more scalable. But if you basically have a prompt that is trying to select between 3 to 5 things and it can reliably do that with just the JSON in the body of the prompt, then I would recommend that don't change it if it's not broken. Great. We'd love to hear about your best practices or cases where function calling is currently capable of doing very well, and what are its current limitations. So I think the areas where it does really well is in kind of selecting between actions that are quite different. So like in the customer service use case, if I'm reaching out and I might have a question that needs to go off to a knowledge base, that's kind of one area that can be pretty distinct, where if I'm asking for something that's very transactional, they're typically the transactions are going to be different enough that the models are going to be able to differentiate between those pretty well. We talk about customer service, but I should mention that the multi-agent framework that we discussed can be applied to a lot of other types of scenarios. So basically any interaction where you have a human talking to a customer or a user and going back and forth and trying to collect information to then go off and kind of do something, that's something that framework can do quite well. So we've also seen that applied to things like handling inbound sales leads, where people might have a lot of questions about, for example, a car, and they just want to collect a lot of information as they're going through that process. And then you have the ultimate output goal of having them schedule an appointment to come in and see the car. That's something that could be automated pretty well and would do well with function calls. As far as limitations, I think if the tools or the actions that you're trying to get the model to take are either very similar to the point where it's difficult to differentiate between the two calls, that would be a clear limitation. Or also if it's very diverse, having one function with tools that do very different things might be a failure mode as well. Cool. So the next question we have, how to optimize speed and cost when I have so many functions. So it's a good question. We typically recommend that, again, that you try to keep it down to a smaller number of functions. And if it's getting kind of too bloated, then you would want to break that out into multiple agents. And that there is that handoff of it being a little bit less efficient, because if you're going from one agent to then one agent that routes to 5 different agents, then that is an extra API call that's happening in that scenario. But we do see that kind of being much more powerful in that scenario. So I think if you have 50 function calls, then that's going to be a lot of tokens used every time you're calling the model. Where if you break that out into one that routes to another one that has, if you have one that has 5 tools that then routes to another one that has 10 tools, that's going to be ultimately smaller prompts and pretty efficient with a faster model like GPT-4o. So I think we have time for 3 more questions. So I have those in front of me, and then we will wrap. So the next question, in function calling, what is the best practice to avoid potential indirect prompt injection in the wild? Great question. So when we're dealing with prompt injection, for anyone that's not familiar, that's basically like you're trying to hack the prompt. So you're either trying to tell the model to forget all of its instructions and do what I tell you now. A lot of times people will say like, be a good bot and like forget everything that I told you previously and do what I tell you to do now. Function calling can actually be a great tool to prevent that type of behavior because you are basically restricting what the model is allowed to do. It's not going to be allowed to just like respond with any type of information. It is specifically trying to figure out how, like the instructions that you give the model is like you are trying to decide between these 5 things, and if you don't have the information you need, then go back and ask the user for the information you need. So if they then go off and ask like something wildly different, instead of the model being able to answer that and hallucinate, like you're going to try to restrict that. That's where we recommend like having those kind of escape valve as well. So if you have like the 5 functions that you wanted to choose from, maybe you have the like 6th function that is like an escalate to human or like a refuse to answer or something. So if you're getting a lot of kind of irrelevant inquiries coming in, that the model knows how to handle that gracefully. And for a next question, is there a way to get some level of confidence score on the selected functions? We do not have that at this time, but that is good feedback. I know we have members of our engineering team that work on the APIs, work on function calling specifically, that are either watching this call or will watch this call. So we'll provide that as feedback. And last question, how do devs estimate tokens for function calling? So this is a great question and can be a little bit tricky. So we can't share exactly how the tool call syntax is injected into the system prompt, but we can share that that information is basically added to the system prompt. So it does count against the token limits that you have when you combine the system prompt and all of the other messages that are queued up. So roughly, it's going to basically be the JSON schema that you define. So if you define that tools and you have like your list of tools in like a JSON array, more or less, that's basically going to be the number of tools. So if you were to run that through tick token or something to count the tokens, that would be more or less how you would be able to do that roughly. I think we are considering shipping an API around helping people figure out exactly how many tokens their requests have. So if you want that, that's good feedback. And we will share that with our product teams as well. So I think that is it for questions. You want to help close us out?
Close us out?
Yeah.
Sure. Thank you everyone for joining. So many great questions that are continuing to come in. We will follow up with as many as possible. Keep an eye out for that email from us, a couple action items there. Would love to hear more feedback as we continue to create these build hours so that they best serve you. And then also sign up for our next one on fine tuning. It's going to be kind of a double click on some of the topics that Joe went over today. And we appreciate you spending an hour of your day with us. We'll see you soon.
Thanks, everyone.